Hello guys and welcome back to Cao 2025. If you watched my last video, you know we dove into LTX 0.9.8 13B and created some mediocre videos. But let's be honest, the base results often look very weak and low quality. Today we're not just creating videos, we're maxing out the quality. I'm going to show you the workflow for upscaling the latent and adding detail to push LTX to its absolute limit. Just a quick reminder, this video is a direct continuation of the LTX video generation workflow we built last time. If you haven't seen that original setup, click the link on video description and watch it first. You'll need that base workflow ready to go before we start adding nodes. To begin, we need the specialized model. Go ahead and download the LTX Video Spatial Upscaler 0.9.8 model, link on video description. Save it on ComfyUI /models/upscale models. Rename the model into LTX Video Spatial Upscaler 0.9.8. Sentences to avoid confusion. We're kicking things off by adding the LTXV Latent Upsampler model loader node. This is crucial for loading our new upscaling checkpoint into the workflow. Set the spatial upsample to true. This setting will focus on increasing the resolution and visual detail of each frame, while temporal upsampling focuses on improving the frame rate or temporal consistency of the video. Next, we connect it to the LTXV Latent Upscaler node. This is the heavy lifter where the actual upscaling calculation happens based on the loaded model. LTXV Advanced Latent. Finally, add the LTXV Advanced Latent node and set the factor to 0.25. This node performs adaptive instance normalization (ADA-in). It helps to blend the newly upscaled high-resolution latent, the latent input, with the original low-res latent or the reference input. This preserves the video's original style and color characteristics while letting the new details blend in gracefully. A factor of 0.25 provides a subtle but effective blend. The upscaling is done, but we're not finished. Now we add detail using a specialized sampler, the LTXV Tiled Sampler. Connect the model, V, noise and the latent to this node. For sampler, we use gradient estimation. For sigmas, we add basic scheduler set to 30 steps with a linear quadratic schedule and denoise 0. Crucially, notice how the sigmas are passed through the SplitSigmas node. In our setup, we're taking the sigmas from the scheduler and telling the SplitSigmas node to separate them at step 18. We then feed only the low sigmas output into the LTXV Tiled Sampler. Why only low sigmas? Low sigmas correspond to the final, subtle detail adding steps of the diffusion process. By setting the split at step 18 and using only the low sigmas, we are instructing the sampler to exclusively refine the fine, high-frequency details on the already upscaled latent. Now, to ensure these new details look great, we use the STG Guider Advanced node. This is a powerful component for steering the diffusion process. Notice that we have CFG star rescale set to true. This is a powerful technique to prevent oversaturation or blowout by automatically adjusting the influence of the CFG scale, especially when adding fine details. The skip step sigma threshold is set to 0.997. This dictates when the guider begins influencing the sampling process. It kicks in near the start of the diffusion steps to ensure good overall composition. Finally, we are using the 13B distilled preset from the STG Advanced presets, which is optimized for the LTX 13B model to generate high-quality, stable results. By combining the LTXV Tiled Sampler with the STG Guider Advanced, we are simultaneously sharpening the image and ensuring the new details adhere to a stable, high-quality composition. This version directly references the key settings visible in your image and provides the technical context for why those nodes are used during the detailing phase. Now we have a high-resolution, detailed latent. It's time to turn it into a video. Instead of the regular VAE decode, we're using VAE decode tiled. What it does, standard VAE decode tries to process the entire high-resolution image at once, often crashing due to VRAM limitations. VAE decode tiled breaks the image into smaller manageable tiles, decodes them one by one, and then stitches them back together. This is necessary to process our much larger upscaled resolution without running out of memory. We need to ensure we have the correct settings here, which are optimized for LTX video. Tile size, set this to 1280. This defines the size of the patch the VAE decodes at once. Overlap, set this to 128. The overlap ensures smooth transitions between the tiles, preventing visible seams in the final image. Temporal size, set this to 256. This is critical for video. Defining the length of the clip processed in memory for consistent decoding across time. Temporal overlap, set this to 32. This overlap ensures smooth temporal transitions or consistent motion between the chunks of video. Almost there. Now for some post-processing polish. We'll use Rife VFI for frame interpolation. This is essential for smoothing out the movement and making the video look more fluid, especially after upscaling and adding detail. Finally, add the LTXV film grain node. Set the intensity to 0.01 and saturation to 0.50. Film grain subtly helps to hide minor compression artifacts and texture inconsistencies, giving the final output a more cinematic, organic feel. Connect the final output to the video, combine node and render. Alright, here are the results. The quality jump is undeniable, the detail is much sharper and the motion is smoother. But here's the honest truth. Even with this enhanced workflow, the results are still arguably under what we can achieve with the speed and efficiency of models like WAN 2.1 or newer video models like 2.2. And as we saw, this process takes quite a while longer than the base generation. It takes about 15 to 20 minutes. It's a fantastic way to push the limits of LTX 0.9.8, but it comes at a significant cost in time and resources. Let me know in the comments if you try this out. If this workflow helped you get better video results, hit that like button, subscribe for more tutorials. Thanks for watching and I'll see you in the next video. Have a nice day, please subscribe.